Welcome to Honors Geometry, Lesson 5.2, talking about the perpendicular bisectors of a triangle. Okay, before we move on, I guess we should talk about what a perpendicular bisector is. There it is. A perpendicular bisector is a line that is perpendicular to and bisects a segment. And if you remember when we bisected a segment using a constructions, a straight edge and a compass, well, what we made was a perpendicular bisector. Alright, so again, this is how it works. We introduce a new section, give you a definition. There's a definition right there. Here comes the theorem. The perpendicular bisector theorem. In a plane, if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. I'll let you pause that, write it down, and once you get it written down, go ahead and then move on to the next screen. Okay, we have segment ZX. Could be line ZX as well, perpendicular to and bisecting segment AC. What the perpendicular bisector theorem says is that segment AZ and segment CZ, that those two segments are congruent because Z, since it's on the perpendicular bisector, is equidistant from the endpoints. Likewise, segment AX and segment CX, they're also congruent to each other because X is on the perpendicular bisector, so it has to be equidistant from the endpoint. So XC and XA have to be the same. That's what the perpendicular bisector theorem says. Now, the perpendicular bisector converse says, in a plane, if a point is equidistant from the endpoints of a segment, then it has to lie on the perpendicular bisector of the segment. So here we have O that is equidistant from the endpoints of a segment. It's 25 units away from both M and N, so that means that O must be on this perpendicular bisector PQ. That's what the perpendicular bisector converse says. Go ahead and pause and write that down and then move on. The circumcenter theorem says the three perpendicular bisectors of a triangle intersect at the same point. That means that they're concurrent. That point of concurrency is called, get used to that term, point of concurrency. You will hear that several more times this chapter. That point of concurrency is called the circumcenter, and it is equidistant from all three vertices of the triangle. So here we go. I'll give you a nice picture of that. Are you ready? There you go. I have a blue perpendicular bisector of segment BC. I have a black perpendicular bisector of segment AC. I have a green perpendicular bisector of segment AB. Z is the point of concurrency that's called the circumcenter. It is equidistant. It's the same distance from C as it is B as it is A. Z is equidistant from the three vertices. And I have my handy dandy compass here to show you that it is actually equidistant from the three vertices. So I'm going to draw this circle And notice that it hits all three vertices. That circle hits C, B, and A. That's showing you that it is equidistant from the endpoints. It is also why it's called a circumcenter, because we just circumscribed, drew around a circle around that triangle hitting the three vertices. That's why Z is called the circumcenter. This will end lesson 5.2 Honors Geometry. Goodbye.